Good morning. Today we are going to be working on geometry lesson 7.5, where we're identifying similar figures using angle-angle postulate, side-side-side similarity, and side-angle-side similarity. And so it's important to know that we are talking about similarity of triangles, okay? Triangles. And this supports Geometry IXL lesson skill M9. Don't forget to take notes on this. Make sure you put your header on it and upload it to me by 1:59 p.m. Saturday. Okay? All right. So, let's talk about using angle-angle, side-side-side, and side-angle-side to determine triangle similarity. So we're going to cover three ways to prove that two triangles are similar, and we're going to use these three, one's a postulate and the other two are theorems, as shortcuts. So these are shortcuts for proving similarity. Not congruence. Okay? Shortcuts for proving similarity. And of course they involve triangles. So here's the similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So here we have angle JKL, and it's congruent to angle XYZ here, and then we also have angle this is KJL, congruent to angle YXZ, and I guess we've already shown you that. So we've got two sets of each, and therefore that makes these two similar, even though the size of these two triangles is different. So remember, similarity, the lengths can be greater or less. They will be, in fact, and the two angles must be congruent. Now, it just so happens that, just so you know, the third angle will also be congruent, but all you need to do is prove two. Okay? All right. Let's move on. All right, so let's prove that the two triangles that you can see inscribed here inside this geode are similar using the angle-angle similarity postulate. So this is a cute little way of showing this. So the picture to the left is a tourmaline crystal, if you're interested, and two angles are inscribed in it. So you see them in there. In the triangles, each vertex angle measures 52 degrees. So when you look at these, remember it's we've been told that it is a similar triangle, and so we're told that the vertex angles are 52 degrees. So why are the angles similar? That's the question. So what's the answer to that? Well, again, it's going to, in short order, it's going to be the angle-angle postulate. Okay, and so what we can do is we can say, because the triangles are isosceles. Why are they isosceles? So you can see there's tick marks in here to show that that they're isosceles, and because the triangles are isosceles, you can determine that each base angle is 64 degrees. Now, why so? Well, we were told that this was a the vertex angle was 52 degrees, And so if you subtracted 180 from 52, you would get twice what 64 is, which is 128 degrees for the rest of the interior angles of the triangle. And since this is an isosceles triangle, then those two base angles have to be 64 degrees. That's how you prove it up. Okay, so using the angle-angle similarity postulate, you can conclude then that the triangles are similar. Because we have 64-degree angles, they're both similar, and you also have the 52-degree. You could choose. I would choose the vertex angle and one of the base angles, but you could use the base angles if you want to determine that you have congruency. So again, using the angle-angle similarity postulate, you can conclude that the triangles are similar. And I'm going to use not only the word similar, but the notation symbol, which is this, means similar. So that would be our paragraph proof. Okay. All right. So we're doing proofs with this, and that's very common. And so when we're looking at these, we're proving, and we're going to do some identification too. But a lot of this is going to be proofs. All right. So this is the side-side-side similarity theorem. Again, similarity. These two triangles, ABC and PQR, are two different sizes. You can see that from here. What they are exactly, I don't know. But it does say here, if the corresponding sides of the two triangles are proportional, then the triangles are similar. So if side AB is proportionate to side PQ, AB to PQ, and BC is proportionate to QR, and CA is proportionate to RP, then we can conclude that the two triangles are indeed similar. Okay? So that's what you're trying to show with these. All right? So let's look at another example. So we're going to prove that the below two triangles are similar using side-side-side similarity. Okay? So here's your two triangles. LMN and let's see, and then you have STU, and then there's PQ in here. I'm sorry, RST, and there's another line segment in here, PQ. All right, so it makes it a little bit more interesting, but it's given that RS, here's RS, this whole side here, is proportional or is to LM. This is LM, right? As ST is to MT. So ST is all of this, is to MT. And then, TR, line TR here, here's TR, is proportionate to LN, or NL rather. All right? So we want to prove, now it's given, these are all proportional. These three sides are proportional. Side similarity is what we want. So we're just saying they're all proportional. Prove that the two triangles are similar. Okay? So our paragraph proof then. Okay, so we're going to locate P. We're going to locate P on line segment RS, so that PS is equal to LM. PS is equal to LM. Let's look for LM. Here's LM. All right. So, how can we tell that? Well, let's find out. So, locate P. on line segment RS so that PS equals LM. Now, then draw PQ, line segment PQ, so that PQ is parallel to RT. Okay. So locate P on RS, here's RS, so that PS, this part here, equals LM. So PS here equals LM. Now we can see that. There's a tick mark here and there's a tick mark there. So that's what they're showing us. Now draw PQ so that PQ is parallel to RT. Well, these are given. So these are really givens, right? These are givens. We already have this information. So we can take this to the bank. Okay? All right. So then we can say that triangle RST, whoops, is similar to triangle PSQ by the angle-angle similarity postulate. Now that's not what we're trying to prove here, but we can prove that because they have two sets of angles that correspond, that are congruent, so they're similar. So the triangles are similar. So then that means, let's see, and we can say, and RS is to PS, in other words, proportional, and ST is proportionate to SQ, and TR is proportionate to QP. So RS, here's RS, is proportionate to PS. So RS is the whole thing is to the part piece, as ST, the whole thing on this side, is proportionate to SQ, which is this part here, okay? And TR, here's TR down here, is proportionate to QP right here, okay? That's what they're telling you, okay? So because PS equals LM, then you can substitute in the given proportion and find that SQ equals MN and QP equals NL. So let's just write that. Because PS is equals LM, so that's their lengths, algebraic lengths. You can substitute in the given proportion one we just gave you, okay? And find that SQ, again, it equals, its length equals MM, and QP equals ML. Its length, QP, equals the length of NL. So by side-side-side congruence theorem. It would follow that triangle PSQ is congruent to triangle LMN. But wait, we're still trying to prove similarity. So finally, let's use the definition of congruence triangles and the triangle and the AA similarity postulates similar to LMN. So congruence of these sides and that triangle PSQ, here's PSQ, this little triangle in here is congruent to LMN, these two, okay? They're congruent to each other. So now we're putting it together and we can say, finally, as I said, use the definition of congruent triangles. I'm going to use the congruent sign, triangles, and the angle similarity. I'm going to use the similarity sign postulate to conclude that triangle RST is similar to triangle LMN. Oops, LMN. Okay, so there you have it. All right, let's see now. What do we have left here? Well, let's look at these two triangles. Which of the two below are, which two of the three below are similar? So we're looking at these three triangles. Now I just put this in here, and you can go through it because basically what we're looking for is proportionality. So you look at the ratios, and they're showing you that the ratios which are similar and which are not. And it's because all of the ratios are equal for triangle ABC and triangle DEF, the two are similar. Okay. But for triangles ABC and GHJ, you'll find that not all of the ratios are equal, and therefore this set is not similar. So we know that ABC is similar to DEF, these two here. Okay, so I'll let you go through that in greater detail on your own. The last similarity is side angle side similarity. And again, if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides of these angles are proportional, then the triangles are similar. Side, angle, and a side is what you're looking for here. So that's what this is showing. Okay. All right, so we're going to do the same thing with this. We're going to prove that two triangles below are similar. And what I'm going to do is a short addendum to this with a separate, very, very quick lesson video to do this last part, because I'm going to have to stop now. And we will get back with you later. So we're nearly done. We'll finish this and come back to it. Thank you very much.